How do you get better at software development? There's so many possible answers, and today we're going to look into abstractions. Why abstractions? Well, because understanding them will help you in three different ways. First, of course, just being able to understand the abstraction when you encounter it in some code. But more importantly, you can wield these abstractions to create simpler, more reusable, and better encapsulated code. And third, you will be better equipped to fix problems fast when, not if, they occur. So along the way, I'll show you a few concrete examples of this in action. So let's get started. So we can think of abstractions like a car's dashboard. It simplifies everything, so everyone with a bit of instruction can operate a car, but you don't necessarily know all the complexities under the hood. That's what the mechanics are for. And for software, we are those mechanics. When we talk about abstractions in software development, then they exist on many different layers. All of them are intending to hide some of the complexity, so that we can get more done in a simpler way. An abstraction can be on a very high level, like a services API. And if you go down the layers, you encounter things like frameworks, data structures, caches, file systems, runtimes, operating systems, and so on. If you have enough time, it's super interesting to peel off these layers of abstractions one after another and look even deeper under the hood. However, that is not what all of us should do. Most developers will not write assembly code, drivers for some hardware, their own file system, etc. And also, the further down you go, the more reliable these abstractions become, simply because everyone else is building on those same abstractions. And yeah, I know the XKCD comic, but it's not something for everyone to worry about every day. You may live an entire career in software development without ever encountering an error in one of those lower layers. So we started off with our first advantage being that you can understand these abstractions when you encounter them. I think that one is rather obvious. So let's jump right into the second reason why you should learn more about these abstractions. So how do abstractions make our code better? As we already said, they simplify things, they hide complexity. APIs are a good example, as are data structures. You don't need to understand what's going on within these to be able to use them. Another advantage is encapsulation. If the abstraction is well made, it doesn't just hide some random stuff, but it encapsulates meaningful behavior, so that we can reason over what the abstraction does without needing to understand how it does so. We had a good example in one of my refactoring videos where we introduced an abstraction in the form of an interface. This allowed us to make the code much simpler. A third strong reason in favor of abstractions is their reusability. Data structures and frameworks are probably the best examples, as we all use them in lots of different projects. But even with one piece of software, you want to find abstractions for the things that you do over and over. Things that you want to encapsulate maybe in order to potentially replace them. Here's another code review video where we did just that in order to be able to switch between different LLMs. With all of these advantages, we also have to consider the disadvantages. While the abstractions may be super simple on their own, we need to understand a lot of them as developers. And that puts a burden on us and our mental capabilities. So while there's value in abstractions, there's also value in not going overboard with them. A simple guideline to achieve this balance is to not mix multiple abstractions in any one piece of code. Check out my video on the single level of abstraction principle if you want to learn more about that in detail. And if you enjoy these sort of videos, or even learn something from them, please hit that subscribe button. Leave me a like and let me know in the comments what your experiences with abstractions are, and if I should do another video on a specific one. I promised to show you this concept in action. Here's an example, and it's built on the abstraction of the enumerable, which is just like Java. It's a stream. It's like giving us, in this case, integer numbers, one after another, as long as we keep asking it, and it's not done. So it could be a generation process that creates these. It could also be just a fixed array being interpreted as an enumerable. In this case, we implemented ourselves and said, yeah, well, first return a 1, then return a 2, and then we introduce some problem here. And so okay, let's throw an exception. Something's going wrong, apparently. We have a test to cover that and find these problems. And when we run this test, we notice that it succeeds just fine. It's perfectly fine. It's looking for a 1 and finds that. And another curious thing is, if you try like this and say, yeah, sure, there's a 1 in this. Let's check it. Oh, it doesn't work anymore. Now it crashes with this exception. So what's the difference really? Why does this work and the other not? Why is it reaching this case and why not? So understanding this enumerable and how the abstraction works allows us to peel off this onion layer on this contain abstraction and take a closer look what this one does. And we notice if we look through this code that essentially it's calling where. So that is another abstraction on the enumerable, the link queue part. And it's just like a filtered expression where you take one element after another and you evaluate it against this function and see if it's true. And if it is and matches, you're done. In terms of performance, also a very important optimization technique to not search through everything needlessly if one of the early elements already matches what you're looking for. So in our case, this means it looks at the first element and that is fine, it finds it, it's good, and it doesn't even evaluate the other elements anymore. Same if we look for the second one, that will be fine. We can just find the first and the second, and then we find a 2. Perfect. If we look for something like a 3 in this list, however, then we are forcing it to evaluate one step further, which of course leads us to the exception. Now, if you run it, there you go. We have an exception. The problem happened again. And if we do something like this, however, there seems to be a difference. And if we look into the code, we see that, oh yeah, this is doing some convert or cast to collection. And since we only have an enumerable, it can't be cast to a collection. So what it's doing inside is essentially calling toList, which creates a new list and evaluates the whole enumerable and places everything into that list. But evaluating it all, that for us means it's going to crash again. That is how something unexpected can hide behind these abstractions. Like everything looks good here, but still there is a problem hidden in there and we're not encountering it at the moment. And eventually it'll come up and you wonder like, what is going on? Why is this coming up now? But we haven't tested. Why is it not evaluating it? And it's a pretty standard error to have these lazy evaluating data structures and then forget to actually enforce their evaluation, because lazy is really good in a lot of cases. But if you want to ensure that all of them are there, it's a difference. It isn't the same thing. And the abstraction is a thing that is very easy to handle, but it has these tiny little details that you need to look under the hood and understand what they're abstracting over, how they work to fix these kind of problems when they occur. Now we face our typical dilemma as developers. If we want to get better, we need to learn more. However, there are way too many things for us to learn within a limited time frame. As for abstractions, we need to decide how many layers down we want to be able to understand them. There's no debate about the highest layer here. The highest levels of abstractions are what we are building our software with. You need a basic understanding of them just to get anything done at all. This typically covers the framework level. So if you're writing an application with React or Spring Boot or Node.js, you need to have a basic understanding of the framework you're working with. When you go deeper, you will encounter programming language abstractions, typically data structures. My suggestion would be to learn these as well. because these data structures are in use all the time, in all sorts of code. The knowledge you gain is actually more valuable even than the framework, because data structures haven't changed much since the 70s. And most of what you learn for one language can be transferred to the same kind of data structures in another language. On the other hand, your framework may be replaced by the new framework of today, and there might be little knowledge you can salvage. Other higher layers of abstractions are still reasonably valuable to understand, such as APIs or design patterns, though I'd argue they are not as important as the other two. The deeper down you go, respectively, the more layers you peel off, the less applicable this knowledge gets. Unless you work as an operating system designer, you won't be able to make use of that knowledge very often. Don't get me wrong here though, it is interesting, it can be valuable, and it might just be the knowledge needed to rescue your project. But still, learning about higher level abstractions pays off more. They are what you interact with more, where there is less stability and more chance for errors. They are your primary building blocks. It's just like those other things in life. Cars, phones, toilets even. You can probably use all of those. But do you need to understand how they work all the way down to the atomic level? Some knowledge on the higher level is really valuable to be able to fix easy problems on your own. But if it gets too complicated, you refer to a specialist. And you cannot be the specialist for everything. So learn your abstractions, but keep in mind that there is no need to master them all. Thank you very much for watching, and as always, have fun developing.